All right, guys, this lesson is on inscribed angles. This will be your last week dealing with the circle unit. So here we go. What's an inscribed angle? An inscribed angle is an angle with its vertex on the circle with two sides that are chords. So if you guys check out the diagram on the left over here, so angle B is the inscribed angle whose vertex is on the circle, and then BA and BC are the chords. So here's your inscribed angle. Here are the chords that go with the inscribed angle. Second bullet, an intercepted arc is the arc that lies between the endpoints of an inscribed angle. So this arc right here, AC, would be the intercepted arc we're talking about for this inscribed angle right here. So the inscribed angle and the arc have a special relationship, which we'll talk about in the third bullet right here. It says the degree of the inscribed angle, so this guy right here, is equal to half the measure of its intercepted arc. So for example, if I said this arc length was, say, 60 degrees, the inscribed angle would be half of that, which would be 30 degrees. All right. So a little formula, the measure of angle ABC right here is 1/2 of the measure of arc AC. Okay, it's 1/2 the measure of arc AC. Next one up, intercepting a diameter. If an inscribed angle intercepts a diameter, so remember diameters are the halfway across the circle right here, so BC would be your diameter, then it is a right angle. So the angle across the diameter, this could be angle A right here, this would be a 90-degree angle right there. So if you have a diameter, the angle across from it is always going to be 90 degrees. So the measure of angle BAC is 90. Last one, overlapping arcs. If two inscribed angles intercept the same arc, so let's do this. Let's say B and A are the same thing, and their intercepted arc could be right here. If you check it out, angles B's arc is AD, angle C's arc is AD. So if they share the same arc, then the angles are congruent. So in this case, angle B would be equal to angle C because they share the same arc. So measure of angle ABD right here is equal to that guy right there, measure of angle ACD. All right, so one last time, if they share the same arc, the angles are congruent. All right, let's do some examples. Find each angle and arc measure. All right, this guy wants a measure of angle WXY. WXY right here. Well, its arc is 62. I cut that in half to get the inscribed angle. So half of 62 would be 31 degrees. They want the measure of arc DGF. DGF. What is this arc length right here? Well, the inscribed angle is 113. I have to double that to get this intercepted arc. So double 113, 226. Number 3, measure of angle PQR. PQR right here, right? Well, angle Q is across from a diameter. Angles across from a diameter are always going to be 90 degrees. Easy one. Number 4, it wants the arc of BC. That guy right there. Well, a little bit of work here, right? I can figure out this arc right here because I have the inscribed angle. So I double 47. That gives me 94. Then check this out. I have a diameter right here, right? So both these arcs have to add up to 180 because half a circle is 180. So if I take 180 minus the 94, that comes out to be 86 degrees. All right, half a circle is 180. This is 94. Subtract from 180. What's left is 86. Number 5 wants the measure of angle JKL. It wants that angle right there, right? Well, first I got to figure out this arc over here, right? There's 360 degrees in a circle. You got 65 of it right here, 53 of it right here. So just subtract those two numbers from 360. You're left with 242. I have the arc for the inscribed angle. Remember, the inscribed angle is half the arc. If I cut 242 in half, that leaves me with 121. Number 6, couple guys wants angle RST, that guy right there. And then we also got to find angle RUT right there. All right, well, here's what we need. The inscribed angle S, that arc is RT. Same thing for angle U. Angle U's arc is also RT. So I just got to figure out that arc, and then I'll cut it in half to get the inscribed angles. So remember, there's 360 in a circle. Subtract off the 3 measures that it gives you, and what's left will be the measure for the arc right here. If you do that correctly, that arc is 82. Take the arc, cut it in half to get the inscribed angle. So half of 82 is 41. And it's the same arc for both angles, so the other guy is also 41 degrees. Number 7, a little bit of algebra now. Find each value. All right, here we go. This is the inscribed angle. Here's its arc. I have to double the inscribed angle to get the arc. All right, so if I double the inscribed angle, 2 times 8x minus 9, that equals the arc of 158. Double the inscribed equals the arc. Distribute that 2. 16x minus 18 is 158. Add the 18 over. That's going to give us 176. Divide that by 16. Answer comes out to be 11. Same thing over here. Angle M is the inscribed angle. Here's the arc that it goes with it. Double the inscribed, equal it to the arc. So 2 times 67 equals 4x plus 58. If I double the 67, that gives me 134. Equals 4x plus 58. Subtract the 58 over. That gives us 76. Divide that by 4, and that comes out to be 19. Next page. Number 9 says solve for x. All right, well, check this out. Angle x is across the diameter, so I know angle x has to equal 90 degrees. Set the expression 13x minus 1 equal to 90. Solve for x. Add the 1 over. 13 goes to 91 7 times. Number 10. Let's see here. Inscribed angle. We got a little bit of work here. All right. First, I got to find angle y. I'll tell you why in a second here. All right. Angle y's arc is 78. If I cut that in half, I will have the inscribed angle. Half of 78 is 39. And now I can do this. I know all 3 angles in a triangle have to add up to 180 degrees. So if I add up all 3 of these angles equal to 180, then I can solve for x. All right, so we got a 7x. We have a 114. We got a 39. And we got a 6. Gives us 159. That equals 180. Subtract the 159 over. That gives me 21. Divide by 7. X is 3. There was another option to do that one, guys, but I think that was probably the easiest way to knock that one out. Number 11, your job is solve for x once again. We got to figure out the arc over here first. Remember, there's 360 degrees in a circle. Subtract these 2 off to get what's left for that arc AC. If you do that correctly, you're left with 106. Remember, double the inscribed equal to the arc. So I got double this guy, then equal it to the 106. All right, so 2 times 7x minus 10 equals the 106. Distribute the 2. Add the 20 over. And then 14 goes in there 9 times. Number 12, we got to solve for x. So first, let's figure out this arc right here. Double the inscribed to get the arc. So if I double 67, that gives me 134. And then I know this. I know there's 360 degrees in a circle. I'll subtract these two off to see what's left for this arc right here. And then I'll set this guy equal to that arc right there. If you do that, you're left with 106 for arc RS. So this expression has to be equal to 106. We'll set that up. Subtract the 21 over. So 5x is 85. 5 goes in 85, 17 times. Number 13. Okay, which angles are we talking about here? It says this measure of angle FGH, that guy right there, this is 6x plus 21, and arc FJH is all of this. Find the measure of FJH, right? So we got to figure out what is this arc right here? Well, once again, double the inscribed equal to the arc. So I'm going to double the inscribed. 2 times 6x plus 21 equals the arc, 17x minus 28. Distribute your 2. 12x plus 42 is 17x minus 28. I'll subtract the 12 over. I'll add the 28 to the left. That gives me 70. Divide by 5. That goes in there 14 times. But I got to answer the question. I got to figure out what is the arc, right? So I take that 14, and I got to plug it in right there. That comes out to be 210 degrees. 14, what are we talking about? We have angle STU, that guy right there. And we're talking about the measure of arc, SU. So once again, double the inscribed, equal it to the arc. So double the inscribed, 2 times 5x minus 16, equal to its arc, 12x minus 50. Distribute that 2. Next up, I'll subtract 10x to the right. I'll add 50 to the left. That gives me 18. And then 2 goes in 18 9 times. But I got to find the angle STU. So I take this 9 and plug it in right there. That comes out to be 29 degrees. Number 15. Which angles are we talking about? We have angle ABD. That guy right there. And we have angle ACD. This guy right there. Well, here's what I know. These are both inscribed angles, and they share arc AD. So since they share the same arc, angle B is congruent to angle C. If they're congruent, set them equal, solve for x. 6x plus 26 is 13x minus 9. Subtract 6x to the right. Add 9 to the left. That gives me 35. And then 7 goes in at 35 5 times. Find arc AD. All right, so here's what I got to do. I have to plug it into either one of the inscribed angles. I have to double it to get the arc. So let's plug it just back into that one. Doesn't really matter. I plug it back in there. That gives me 56. So angle B is 56 degrees. I double that to get the arc. This arc would be 112 degrees. That's your answer. Double the inscribed to get the arc. 16, we're talking about angle KJL. That guy right there. Angle KLJ. That guy right there. Find KL. Well, check this out. I know I have a diameter right here, right? Any angles across the diameter are always going to be 90 degrees. Then I also know 3 angles inside of a triangle have to add up to 180 degrees. So I add up all 3 of these angles, equal it to 180, then I can solve for x. I got 3x, so 7x, there's 10x. Let's see. I have a 2, a negative 32, and a 90. That gives me 60. Equals 180. I think I did that right. Yep. Subtract the 60 over. That gives me 120. 10 goes in there 12 times. Let's see. Find the measure of arc KL. So I got to find this arc right here, right? So here's what I have to do. Plug it into angle J, then double that to get the arc. So plug this in right there. Let's see here. 3 times 12 plus 2 gives me 38. So angle J is 38 degrees, but you have to double that to get the arc. So I double 38. That gives me 76 degrees. That is your answer. Next page. This one's going to be kind of fast, guys. Inscribed quadrilaterals. So remember, quadrilaterals are a 4-sided figure. There's some special properties if you have a quad inside of a circle. Says if a quad is inscribed in a circle, then its opposite angles are supplementary, which means they add up to 180, right? And I also know this, if we look at the diagram, if I take angle A plus angle C, that equals 180. And the other ones, if I take angle B and add that with angle D, that also equals 180. Remember, there's 360 degrees inside of a quadrilateral, and the opposite angles are supplementary. So angle A and C add up to 180, angles B and D add up to 180. All right, 9 more, and then we're all done. Find each value or measure, angle J. Angle J hooks up with angle L. These two guys add up to 180. So if I take 180 minus the 92, that gives me 88. K and M add up to 180 because they're opposite. So 180 minus 45, 135. Opposite angles add up to 180. Let's see here. The quickest one I can find now, Q and S hook up, right? So I take 180 minus 93 to get angle S. Angle S adds up to be 87. And a little bit of work here. Let's see, inscribed angles. If I'm looking at angle R, right, this guy right here, his inscribed angle is all, the arc for this inscribed angle is all of this, right? So if I add up these two right here, the 90 plus the 126, that gives me 216. Cut the arc in half to get the inscribed angle. Half of 216 would be 108. So angle R is 108. And a couple ways you can find the last one. I'll just give you one option. Remember, there's 360 degrees inside of a quadrilateral. So if I just subtract these 3 guys from 360, I'll have angle P. If you do that correctly, that comes out to be 72 degrees. That was a long way, but that's the shortest way to find that one. Number 3. All right. Quickest one to find, angle W, right? Opposite angles are 180. So 180 minus 51, that gives me 129. Kind of like number 2 now, I'm going to find angle X next. Angle X's arc is all of this. 101 plus 67 gives me 168. Cut that in half to get the inscribed angle. So half of 168 is 84. So angle X is 84. And then just like last one, you have 360 degrees inside of a quadrilateral. Subtract these 3 guys from 360. Angle V, you're left with 96 degrees. Okay, number 4, they don't give you any inscribed angles, right? So now we got to use the arcs and cut those in half to get some of the inscribes. Let's take a look at angle D first, right? Angle D's arc is all of this. So if I were to add those up, that would give me, let's see, 100. Cut that in half to get the inscribed angle. So angle D would have to be 50. For angle A, let's grab a pencil. Angle A's arc is all of this, right? So 61 plus that 47. And that gives me 108. Oop, 61 plus 147. How about 208? All right, so I cut the 208 in half. That gives me 104. So angle A, 104. Now I can do some opposite angle stuff, right? Angle D and B hook up. These guys add up to 180. So 180 minus the 50, that's 130. A and C hook up. 180 minus the 104, 76. Number 5. Opposite angles add up to 180, right? So just add these two up, equal it to 180. All right, so we got a 9x. I got a 68 and a negative 5, so that's 63. Equals 180. Subtract 63 over, that's 117. Divide that by 9, 13. 6, same thing. Opposite angles add up to 180. Combined like terms equal it to 180. You got a negative 5x. I got a 133 and a 62. That gives me 195 equals 180. Subtract the 195 over, that's negative 15. Divide by negative 5. X is 3, not 5. Number 7. All right, what's the solve for x, right? All right, well, this inscribed angle goes with all of this arc over here, right? So let's figure out what this arc length is, and then I'll double the inscribed, equal it to the arc. All right, 360 in a circle. 360 minus the 135 minus the 91. Let's see what that leaves us with. 360 minus 135 minus 91. 134. All right. Double the inscribed, equal it to its arc. So if I double the inscribed, 2 times 15x minus 23 equals the arc 134. Distribute the 2. 30x minus 46 is 134. Add the 46 over, that gives me 180. And then 30 goes in there 6 times. All right, number 8, same concept. Angle J's arc is all of this. To get that arc, add these two up, subtract from 360. All right, so 360 minus 50 minus the 96, 214. Double the inscribed, equal to the arc. 2 times 12x minus 25 is 214. Distribute the 2. 24x minus 50 is 214. Add the 50 over. That gives me 264. And then 24 is going to go in there 11 times. Last one. All right, we're talking about angle W right here. We're talking about angle Y right here. This is find Y, right? Well, these are opposite angles inside of a quad. We know that they add up to 180. So combine like terms, equal it to 180. 5x, 13x, 18x. 1 and negative 37 is negative 36. Equals 180. Add 36 over 216. 18 goes in there 12 times, but I got to find an angle Y, right? Just plug it back in right there. And that comes out to be 119 degrees. The last page, guys, you can do this one on your own. It's just a little circle challenge to see if you guys are able to figure out some angles with the given information at the bottom here. Could you guys check out the notes that go, the key with the notes? I give you guys the key and you can kind of check out how you guys did if you want to. So that's up to you guys, but make sure you pay attention to those first three of the notes and then knock out that assignment. That's it.